this time. So module 2, we're going to be looking at displacement analysis. And really, in a nutshell, it's taking those kinematic diagrams and we are going to be moving the input around and then seeing how the other mechanisms are going to kind of follow along. Okay. I saw that there was a message up here. Okay. So if we look at the learning plan here for module 2, you're going to notice that we are going to be working out of chapter 4. Okay. We will go back and we will look at chapter 3. But for right now, the sequence just seemed to make sense to go from chapter 1 to chapter 4 for just reasons. I just think it's sequenced better. And then you're going to notice there's a couple other resources here, which we will be looking at the next time we're together. If we go back to our module, you'll notice that there are also session recordings. The ones that are out there right now are the ones from last fall. Okay, so feel free if you wanted to, again, work ahead or look at those, but virtually the same information is going to be covered starting this evening on this section as well. And then you're going to notice that we do have practice problems. We are going to get started on these tonight. So example 4.1 and example 4.2 are the two examples we're going to go through start to bottom. And then what we'll do is we'll start a file for your module to practice problems, and then we'll add the examples that we see here the next time we're together. Okay, so we'll get started on that. And then you'll notice that we do have assignment 2. Looks like a lot again, but I'm going to tell you that the 1, 2, 3, 4, 5, 6 problems that we see right here, even though there are 6 problems, it's actually 3 start diagrams, and then you're moving them around in 2 different ways on each one. So really, the drawing is going to be minimized because they're going to have the same base sketch for each one of those. Okay, so we'll look at that when we get done tonight. So you'll be able to, with the work that we do this evening, be able to get started on that assignment by doing the first 6 problems related to what we're doing today. So let's go over to our learning plan, and I'm going to pull up the PowerPoint presentation. And like I said, we're going to be working out of chapter 4 in your book. Chapter 4 starts on page 72. And it's called position analysis. Okay, so the objectives here, I'll kind of go through these, are first of all, defining position and displacement of a point. They aren't the same thing. Position, we're going to find out, is just like in space where that point is at, and displacement is how far did you move? Okay, and there's a couple different types of displacement. Then you're going to notice here, we're going to determine the position of all the links in a mechanism as that driver link moves. It's one thing to move one of them, but we can't say it's going to mirror the same on all the other links because they're different lengths and different orientations and such. So what we're going to do is we're going to graphically move our driver and then see how everything else kind of follows along. Okay. We're also going to determine the position of all the links in that mechanism when we go through an entire cycle. And basically what an entire cycle is when we take the driver and we move it around in a full circle, okay? Not just a couple degrees. We're also going to be determining what we call the limiting positions of a mechanism. It's kind of like the furthest and the closest positions that the output is going to go as we move that input. And then lastly, we're going to learn how to plot a displacement diagram. So the things we're going to be doing tonight, I think, are like the first 2 or 3, okay, that we're going to be covering. So kinematic analysis. Kinematic analysis is going to be when we determine the location of all the links as the driving link in a mechanism moves to a new position. So what is happening everywhere, basically. Now, kinematic analysis can do the following. We can determine the full motion. So we can move that driver link all the way around, if you would, a full cycle. Determine positions of all of those other links, including the driver. We can determine the extents or the range of motion, and then also determine the spatial requirements. Now, again, these are all things that are in that first stage of the design process. Most often, even though we're going to have diagrams that we see what the final product looks like, most of the time you don't have all those details in place yet. You might have a box of space that you can work in, and then the job that you need to do or the function you need to do has to fit in that box. And so kinematic analysis is, again, those first steps of doing that. Now let's talk about position. Position of a point on a mechanism is its spatial location in relationship to the rest of that mechanism in space, okay? So the primary goal of position analysis is really just to determine the location of the points of the mechanism relative to that crank or driving link, okay? Now, displacement is going to be the end product of motion, okay? Typically, and we already started doing this. When we were in module 1, we drew the position of a mechanism in like its home position, like just like this, like just draw this position. And we're going to find that we're going to do that. That's going to be where we start. And if you would, that'll be like the home position. Then what we're going to do is we're going to move the driving link or the crank a certain amount, and then we're going to see how the other links follow along. Once we determine from that home position to where those links moved, that is displacement. It's kind of like the difference between a before and an after, okay? Now, there's two different types of displacement. There's linear displacement and there's angular displacement. Linear displacement is a straight line distance. So our sliders are going to have linear displacement, okay? They're going to have a start position, and then once we move things on the mechanism, where do they end up? That difference is going to be linear displacement, straight line. And then the other type of displacement we have is angular displacement. Okay, angular displacement is going to be how many degrees of motion do we go through. So if something is fixed to move about a center of rotation, it's going to have angular displacement. If it can move side to side or linearly up and down, side to side at an angle, whatever it might be, then it's got linear displacement. Okay. Now, we're going to be looking at all of the problems that we do, not only in this module, but going forward, we're going to be using the graphical method or graphical solution or graphical analysis. And the reason we're doing that is you're going to notice that in combination with in this book, there's usually going to be a section in the chapter that's going to do graphical analysis so we can draw it all out, just like we are in AutoCAD. And we're going to continue to do that. Accompanying that, there's usually going to be an analytical part to it, meaning it's going to be where you use the algebra, the trig, the calculus to determine the beginning and the end results, okay? Now, if you love that analytical method and you want to explore that, that's totally something you can do on your own. But with 8 weeks for this class, and the opportunities that you have in other courses to do a lot of different calculations, physics, statics, strength of materials, all that kind of stuff. You get a lot of analytical. We're just going to stick to the graphical, okay? I trust that you can do the analytical, and to me, it's just spending extra time on stuff that you've already got a good handle on. Does that make sense? Okay, so we're going to stick to graphical solutions here. So what you're going to notice is in our chapters, we're not going to be covering every one of the sections, okay? So your PowerPoint presentation will always be your guide for the sections that you're responsible for, and they're going to be the places that we stop along the way and do examples and things, okay? So graphical analysis, the process that we go through, or the main steps that we go through, are going to be basically, number one, drawing that kinematic diagram of the mechanism in whatever its home position is, okay? However it's being seen at that first state, if you would. We're going to also always calculate the degrees of freedom, because that confirms that we have a good diagram, okay? If we know the final function and we can say definitively or confidently how many degrees of freedom there are, then we should be able to get that number, and then that confirms that we have the right amount of links and the right amount of joints identified, okay? After we're done with that, then we're going to move the driving link the desired position, okay? And then we're going to determine what the position of the remaining, what we call slave links. The slave links are the ones that are dependent or are moved relative to that input or that driving link, okay? So there are a couple of illustrations we can look at here in the book. So again, we are starting on page 72. This is chapter 4. I'm going to turn the page here. And if we look at diagram 4-5, okay, this is just a simple 4-bar mechanism, okay? And you're going to notice here that we have the frame identified here at the bottom. The first link, link number 2 after the frame, is considered what we would call the frame, or I'm sorry, the crank or the input, okay, or the driver. And then it's connected to the connecting rod or the connecting link, and then back to the frame. So we have 1, 2, 3, 4 links, or a 4-bar mechanism. So then you'll notice that at each one of the joints, we've got our letters. So A starts here, B is at the end of link 2, C is at the end of link 3, and then this would be D. D would be at the end of link 4, okay? So we've got 4 links and we've got 4 primary joints, okay? Now, the process that we're going to go through, first of all, we've got our home position, and that's what we see with the solid line for each one of the members on our mechanism. We're going to be moving then our driving link, or the crank in this case, to a new position. In this case, you're going to notice that because this is link number 2 and it is fixed at the end points here at joint A, so that it can only rotate around that fixed center, okay? So its path, if you would be along a circle that would go through, okay? So in this case, this would be what we would call angular displacement. We are displacing it 15 degrees clockwise from its original position. And it's an angular displacement because it's fixed at point A here, okay? It can't move. Another link that's going to have angular displacement is going to be link number 4, okay? Link number 4, you're going to also notice that it is affixed at point D, and it can only move about that center. Now, whether that goes around a full circle or if it just oscillates back and forth, that would be determined through the position analysis of the entire mechanism. But that also would have angular displacement. I would anticipate that it would move to the right as well, but it can only go along that path. So it would have angular displacement, not linear displacement, okay? Okay, again, because of the nature of how it moves. Now, like I said earlier, here, do not have a slider. The example that we're going to do is we are going to be looking at page 76, example 4.1. You'll notice that there's a slider here as the output to this link, or this linkage, or this mechanism, okay? Now, in this case, a slider is also going to have displacement, but it's only going to be along in this case, a horizontal line, okay? It's not going to have angular. So when we have sliders, that's going to be linear displacement that we determine. When we have links that rotate about a fixed center, that's going to be angular displacement, okay? All right, so if we go back over here, we are now going to officially look at example 4.1, okay? So using AutoCAD, we're going to work this example. So we're going to first draw the kinematic diagram, and they actually have the kinematic diagram drawn for us. So we're going to duplicate what they have with the dimensions that they have. Then once we have that drawn, we are going to calculate the mobility, or the degrees of freedom, for this particular mechanism, okay? Then we're going to move on to moving the driver to the desired position as stated in the problem statement. We'll see that in a little bit. And then we're going to construct how to get the other elements in place. And this is really kind of using AutoCAD and its functionality to do this for us, or we're gonna do it using that tool. And then finally, we're going to draw everything into positions, and then we're going to find the measurements or the end displacements that the question is asking for. So if we go to page 76 in our book, okay, so page 76, halfway down is example 4.1. And this example statement is referring to the diagram that we see down here. Okay, so it says in figure 4.11, it shows a kinematic diagram. We are going to duplicate what's here. We're not seeing the final machine. They've already simplified it for us. So we are simply going to draw this in AutoCAD, okay, using our kinematic start file. We're going to graphically, after we have it in this position, we're going to graphically reposition the links in the mechanism as link number 2 is displaced 30 degrees counterclockwise. So when we look up here to the page 77, this is where we move link number 2 counterclockwise 30 degrees. And then we're going to find out, what do all the other links do? What is the end result of that when we do that? Okay. So then we need to determine the resulting angular displacement of link number 4 and the linear displacement of point E. So the angular displacement is going to be, okay, how far does link number 4 rotate backwards? Okay, how many degrees is that going to happen? And then we're going to look at, okay, from this position, how far does this slider move linearly? Okay, so step number 1 is going to be drawing our kinematic diagram. So let's go ahead and go over to AutoCAD, pull up your kinematic start file, and we're going to add a layer. Okay, we're going to add a layer. Because now what we're doing is, if we look at the layers that we currently have, we only have one object line layer, okay? And that object line layer is for a continuous line. And that continuous line is going to be used to draw the home position of our mechanism. When we want to then move our mechanism, okay? So when we want to move, for instance, link number 2 here, instead of drawing it with a solid line, we're going to change our line style to hidden, okay? So that way, when you guys print them out, especially if you're not using the colors, then you can see the difference in your before and your after states, if you would. So we're going to use AutoCAD to do that. So we're going to add a layer here. So we're going to go to Layer Properties. I'm going to click on the object layer and just hit enter. And I'm going to call my new layer Object 2. Okay. Once I have that in there, I'm going to change my color to green, just so it's different than white. You can put whatever color you want, but keep in mind that we have a dark, if you have a dark background or a light background, what looks best. I'm going to use green. And then we're going to change the line type, click on line type from continuous. We need to load, and we're going to pick the first hidden line right here. Okay. And then we're going to hit OK. And then you have to select hidden and then hit OK, and then make sure that it changes to the line type in our dialog box to hidden. Okay. Once you have that in place, we've just added that layer. We can click out of it. And now you're going to notice that we have that second object too. It's really not a hidden layer because we're just using the line type to show another line, like for our mechanism. So for right now, we don't need to do anything there. We just wanted to add that in. It would be a good idea if you wanted to, because going forward, we're going to be doing more examples like this. Wouldn't hurt to do a quick save on that kinetic start file or kinematic start file, so that now every time you bring it up, it's got that second object 2 layer for you. Okay. All right. So now we're simply going to draw this kinematic diagram. I'm going to start by placing my 2 frame members. Notice that here in module 2, we're going to start getting the dimensions now. So we're going to draw these to scale. So wherever we're given dimensions, we're going to use them. So the distance between A and D is 5.3, and the distance vertically between A and D is 3.2. So I'm going to go back over to AutoCAD here. I am going to move my frame member like kind of over to the right here, okay? To kind of give myself room. So this is going to be my A, okay? Then what I'm going to do is I'm going to change my layer to the 0 layer, and I'm going to draw a line, okay? So just arrow down, switch to the 0 layer, and I'm going to click on the line. Now, at the center of my frame, okay, where the circle is. Now, just as a, depending on if you want to do this or not, I kind of got rid of some of my object snaps. So I only have endpoint. So object snaps is this little, running object snaps is this little box with the little box. I don't know how to say it, how to describe it. But if you do that down arrow next to it, I just have endpoint center, and intersection. I got rid of any of the other ones that I normally would have because it was grabbing a lot of different things like quadrants and things like that. So I just tried to make it as simple as possible. So now when I start my line and I go close to that center, it's going to jump to the center rather than to the quadrants. Okay. So I'm going to click on that center and I'm going to move to the right. And I'm going to move to the right 5.3. So I'm going to enter in. I just moved my cursor to the right, 5.3 as a distance, enter. And now it made it that long to the endpoint. Now I'm going to go straight up. And that distance is going to be 3.2, enter. And I'm going to hit escape. Now at the end of that line that I just created up and to the right, that's going to be where I'm going to copy my frame down here at A so that it's going to be the frame at D. So I'm going to hit the copy command underneath move. I'm going to window around my frame, enter. My base position is going to be at the center of the original one here. And I'm going to turn ortho off. And then I'm going to move it or copy it to the endpoint that I just created. Escape. Okay. You could use offsets if you wanted to create this intersection. I just use kind of that dynamic input to do it. Okay. So the bottom left is going to be our A, and then this is going to be D. And I'm going to I'm going to erase those two lines that I don't need. I'm also going to move my call out for number 1 to be by the frame. And then I'm going to move my A right here. I think right here. Okay. Whoops. So it's not so close. And then I'm going to put D up here. Okay. Now remember, when I call the frame 1, I only do that one time. This is another connection to the frame. Don't connect these. Don't call this another number. It's 1 is every single connection to the frame. Okay. We only call it out once. All right. So now if we go back to here, the first link that I'm going to put on is going to be link number 2. Link number 2 is 3 inches long. Okay. I am going to go back to AutoCAD. I'm going to change to my object line layer because the lines here for this mechanism are going to be the solid white ones. So I'm going to take my line command. I'm going to start at the center of A, and I'm going to go straight up. This is a vertical line. Put on your ortho if you need to. And this is going to be 3 inches long. Enter. Okay. Now, I am not going to put the pin connection yet. I like to leave those to the end. Otherwise, I have to try to make sure that I get to the end of them. But what I am going to do is I'm going to move B over to that endpoint so that I know that that is where B is. Put it on this side, I think. Okay. Now, I still have my Kinetic Start file as my file name. I want to change this to example 4.1. So I'm going to do a file, save as, and we're going to call this example 4_1. You can call it whatever you want, but probably makes the most sense. Okay. So now I've got my link number 2, so I can move my circle with my 2 over to link number 2. Okay. Okay, so let's go back and look at what else we've got. So we've got link number 2 in place. So the next thing we want to do is we want to find point C. Okay. Now point C is on the endpoint of both links number 3 and 4. 4 has a fixed center. Okay. So the path of C is going to be on that radius of 3.3. Do you see that? Okay. So what we're going to do is we're going to go back over to AutoCAD, change our layer to the 0 layer because it's going to be kind of like a construction line looking. And now I'm going to put a circle center radius in place. Okay, circle center radius. And it's going to ask me where my base position is going to be. It's going to be right at the middle. And then my radius is going to be the 3.3 inches. It's going to be the length of link number 4. Okay, so 3.3, enter. All right. So that's the point at which C is going to be along. Okay, but where along there, we go back underneath here, we know that it also is going to be on the end point of link number 3. Link number 3 starts at B, and it is then, if we draw a circle with a radius of 4.9, its center at B, where these two circles intersect, is going to be point C. Okay, so let me go back to AutoCAD. We're going to do another circle center radius, but this time our center is going to be at B, and our radius is going to be 4.9. Enter. Okay, so we have two intersections here, but as we look at our illustration, it's going to be the upper intersection that is going to be our point C. So now we're going to change our layer to object line layer. We're going to connect from B to that intersection, and then down, keep going and go to D. Okay, so now what I've done is I have just created link number 3, point C, and link number 4. Okay, so I'm going to go back to AutoCAD, and I'm going to add those labels. So I'm going to move link number 3 to here, and I'm going to move link number 4 to here, and then I'm going to move point C. I'm going to put it here. See, I pick the endpoint. I'm going to put point C here for right now. Okay, so you can see where we got those two intersections, or those two circles from. The center of the smaller circle is the center of D with a radius of 3.3. And then link number 3 is 4.9 inches long, and its center would be at B. So when we struck that arc for both of those, the intersection was there at C. Okay. All right, now going back over here, we need to put in link 5 and our slider, which is link 6. Now, we know that the line of action for this slider horizontally is going to be 0.8 inches above D, okay? So what we're going to do is we are going to create a line on our object line layer, or I'm sorry, on our zero line layer. And I'm going to start at the center of D, and I'm simply going to make a horizontal line, a random length, okay? Then I'm going to offset this up, and offset is 2 below our eraser, offset, and this distance is going to be 0.8 inches, okay? So I'm going to click on that line, and I'm going to move up and then click. So it's going to be 0.8 above, all right? So what I've done is I've created, if you would, the line of action that slider is going to be on. Now, to find where along that line, I'm going to go back to C, and I'm going to strike an arc with a radius of 10.1 inches long, okay? So the center is going to be at C, and the radius, so I'm going to do a circle center radius again. I'm going to start at C, the intersection of C, and I'm going to turn off my ortho, and this distance is going to be 10.1 inches long for the radius, I should say, okay? So now I have an intersection with the upper line, which is my line of action, that's the 0.8 up, and at that center is where I'm going to move my slider, okay? So center of the slider up to the intersection we just created, okay? And then I'm going to go to my object layer once I have my slider in place, and I'm simply going to connect from C to the center of my slider. Okay. Any questions so far? Okay. So now we just want to finish up our labels. Okay. I'm going to get rid of some of these lines because I don't like it so busy. So if you want to leave them on for a little bit, you can, but I'm going to erase this radius, the 3 circles, if you would, okay? And then I'm also going to erase the bottom horizontal line. We're going to need that other horizontal line in a little bit. And if I have to put the other radiuses back in, I will. I'm not worried about it, okay? So it wouldn't hurt to do a quick file save, okay? And then the only other thing that I'm going to do here is I'm going to finish up my labeling and add in my pins. So I'm going to copy my pin connection from this center to the endpoint of B and the endpoint of C, okay? Then I'm going to copy my 4, which is going to become a 5 here and a 6 over here. So I'm going to place it in 2 places. And then I'm going to double click and I'm going to change that one to 5. Double click and change this one to 6. Again, have to click on the outside of it. Okay. And then I need to add my joint labels. So I'm going to copy my D and I'm going to need one by the top here to identify the center of that, the center of the slider. And then I'm also going to show the sliding joint. So this one goes to E. Oopsie, E. And then this one is a sliding joint, goes to F. Okay. All right. I'm going to keep that line in there and F in there for right now. Now, we don't have to worry about an X and a Y. There is no special interest point, so that's totally fine. So if you want to delete those for now, you can. I'm just going to kind of leave them hanging out. Do one more save because I've got my home position done. Okay. So basically what we've done at this point is we have drawn the kinematic diagram, but then now we want to calculate the mobility. Okay. Calculate the mobility. So we're going to go back to AutoCAD, and this is where you have the choice. Remember, there's 3 ways you can show me mobility. You can put it right in the AutoCAD file, which is what I'm going to do right now. You could add it to the Word document or the document that you're going to be putting your screenshots into, or you can hand do it and then hand in that, that calculation. So totally up to you, whichever way, as long as I can read any one of them. So I'm going to change to my notes layer. I'm going to do my M-text, and it's not going to go down below here. So I'm just going to put my M-text right here. So my equation in variable form first is F, capital F, is equal to 3 times lowercase n minus 1 minus 2 times JP. Remember, n, lowercase n is the number of links and JP is the number of primary joints. So as I look here, the highest number I have of my links is a number 6. So this is going to be equal to 3 times 6 minus 1. So you're going to put your numbers in the next line, if you would, kind of like showing your work, minus 2 times. Now, my primary joints, I have A, B, C, that's 3, D, E, and F, that's 6, okay? So it's going to be 2 times 6, enter. So my F is going to be equal to 5 times 3 is 15. 15 minus 12 is 3. Okay. Now you might be like, wait a second, is that right? It is. Okay. We've got 6 links and we've got 6 joints. Okay. No matter how you slice it up, that means that we're going to have to precisely move 3 elements. Now, how they're doing it, we don't know. We don't even know what the final function of this is, okay? And that's okay. So don't be concerned that that's a degree of freedom of 3. It doesn't mean it's wrong. It just means we do need to do 3 things in order to get it to do what we want it to do. Does that make sense to everybody? Okay? And that's okay. It's when we end up with zeros or negative values, or when we absolutely know there's only one thing that we're moving and we're getting a different number. Okay. So, so this is fine. All right. So I've got my degrees of freedom done. Yes, Tyler.
I mean, I don't think it's possible, but is it actually possible to get a desirable -1 or something?
No, a 0 or a 1 is telling you that it's not moving. A zero means it's like a frame. It's supporting something. It's actually not moving. And a negative is just like, then it's not a mechanism. Like we need more, right? It's
You can't go beyond not.
correct. And to be considered a mechanism, right? A mechanism moves. That's just the nature of it. Yeah. Yeah. No, good question. Good question. So the question, if you didn't hear it, if you're virtually, was, is it okay to have a zero or a negative value? And that's what I was explaining. No, not if we're a moving mechanism. You have to have at least 1 degree of freedom. Okay. All right. So now that we have this in its home position, we go back underneath. Our next job is to move link number 2. Okay. And we're going to move that in a counterclockwise direction of 30 degrees as identified in the problem statement. Okay. So that's going to be the next thing we do. So we're going to go back to AutoCAD. All right. And we're going to focus in on link number 2. Now we're going to rotate this link about the center A, but we're going to rotate and copy. Okay. So you got to kind of be careful with this command then. Because if you just rotate and you put your angle in right away, you're not going to leave a copy behind. We want to leave the original there so we can see and reference where that was. So we're going to do the rotate command. We're going to first select our item. Now remember, watch your command line because this will tell you when you have to do this. So I selected the one item I'm going to rotate. Then it's asking me for my base position. This is the center of rotation. So this is going to be point A. All right. And now you're going to notice I can move it. Okay. If you need to turn your ortho off, turn your ortho off. I'm not clicking right now. I want to leave a copy behind. So if you look down at your command line, it says specify the rotation angle or C for copy. Okay. So we want to do C, enter. And now notice that it now leaves a copy behind. Okay. Otherwise, you're going to have to redraw it back in. We don't want to do that. And now we can enter in our reference angle. Positive angles are in a negative or in a counterclockwise direction. So we're simply going to put 30 because it's 30 counterclockwise. And there you have it. Okay. Now we want to signify that this is our new position. So we are going to do 2 things. We're going to change the line type. So you can simply select that new line. We're going to go up to our layers and we're going to put it on the object 2 layer. Okay. The green dashed line. Then the other thing we're going to do is we're going to identify the end point of this new position as B prime. Okay, so it's kind of like the next step. So we're simply going to copy B and we're going to put it over here. I don't want to really go on the end point there. And we're going to double click this and we're going to add a prime in back of it. So B is the original. And B prime is the new spot. Does that make sense to everybody? We don't put a 2 prime because it's still the same link, and it's really the points that we identify anything that literally moves. Does that make sense? Notice A doesn't get an A prime because that is a fixed position, okay? D is not going to get a D prime, but C is going to get a C prime, and E is going to get an E prime, okay? All right. So now we have our new position of B. Then what we need to do is we need to find the new position of C, C prime. Now we know that C is only going to go along the radius with a fixed center at D. So we're going to put that radius back in. So I'm going to go back to my 0 line layer, center or circle center radius at the center of D is our base position. And because C is here, you can go to the endpoint and this is going to be its length, or you can enter in the 3.3 as the radius. Okay. So that's C's path. So somewhere along there is where C prime is going to be. Now, since we have a new position for B, okay, we are going to do our circle center radius. And at the end point of B is going to be the center of our new circle. And the radius is going to be, you guys tell me. What is the radius of this circle going to be? It's going to be the length of link number 3. Did I hear it? 4.9, exactly. So 4.9, enter. Okay. Now, you'll notice that it's pretty close here to link number 3. So when we go in, we've got to kind of zoom in. So now I'm going to go back to my object 2 layer. I'm going to start my line here at the endpoint of B prime, and then I'm going to zoom in. And I got to find the intersection of those 2 circles. Okay. Now, before I leave this line, if you did already, it's okay. But I'm going to go now to the center of D. And that's going to be then my new placement of link number 4. Okay. So good. All right. So then I'm going to add my new, I'm going to kind of move things around here because 3 is actually this side. And then I'm going to move C over here to its, oopsie, I don't want to move that. I wanted to copy it. I want to copy it, sorry. Copy C. And now that's going to be, if I double click on it, I'm going to put a prime. That's my new C prime, okay? And here too, I'm not going to re-put in 4 just moved. Now, one of the answers, or one of the things that we need to determine, is how far, what was the angular displacement of link number 4? We now can see it. This is the angle between these 2 lines. So if I go to my notes layer and I arrow down here under annotation to the angular dimension, okay, click on that. I'm going to left click on both of the lines. And now if I pull it out here, it's 26 degrees, okay? And if we just kind of peek ahead at the final answer, it's 26 there as well, okay? All right, so that's one of the answers that we're looking for, the angular displacement of link number 4, okay? Now that I'm done with that C prime, I definitely can get rid of these 2 circles. So I'm going to just delete these 2 circles out of there, okay? And now I'm going to work on where along this line is my slider now going to be, okay? Now that I have my new C prime, we know that C is connected to point E. We want to know where E moves along this line relative to the C prime moving. So if I look back underneath, the length of link number 5 is 10.1. So I'm going to take that 10.1 as the radius of my circle, and I'm going to start its center at C prime this time, okay? So I'm going to change over to the object 2. I'm going to go to center, radius, circle. The base position, make sure you get right at the center or at the intersection of those 2. Oh, I don't like that I have this on here, but it's fine. 10.1. I like having it as the object or the layer 0, but if you didn't change it like I did, it'll find the intersection here. So now what we want to do is we want to move our slider so that it is now in this new position where, actually I'm going to change, I'm going to left click here. I'm going to change it to the 0 layer. There we go. Then we can see right where that intersection is. And now we're going to move this or copy my slider to the left. So if I go to the copy command, I'm going to copy E and then the rectangle, the center, and I'm going to grab that line and the hatching. They're going to overlap, but we'll move it. So I'm going to copy from the base position where E is right now, and then we're going to go to the intersection right here, okay? Doesn't move far, doesn't move far. And then I'm going to grab the outside of my new E, my new slider, and I'm going to put that on the object 2 layer. They are overlapping a little bit, that's okay. And then you're going to notice I'm going to double click on the new E and add a prime in back of it. And then I'm going to get rid of both of these hatches, okay? We'll put it back in. I'm going to go back to the hatch layer. I'm going to add a rectangle underneath because remember I need an enclosed area. I'm going to put it underneath right about like that. It's fine. And then I'm going to go to the hatch command, which is 2 down below the rectangle. And I want to make sure that ANSI 31 is selected. And I'm going to click, it's going to see this radius, that's okay. And then I'm going to just click in both places. And then I'm going to hit OK. All right. And then I'm just going to select that outside boundary of that rectangle and delete it because we don't want that there. It's just there so we can put the hatch in. Okay. So now I want to see what the resulting displacement was linearly. Okay. Now this is not an angular displacement. It's not going to be an angle dimension. This is a straight line or a linear displacement. So I'm going to go back to my notes layer and I'm going to arrow down and I just want a regular linear dimension. And I'm going to go from the original E to the E prime. And you should get 0.9544. Okay. That is the answer. Yeah. Okay. And then all I'm going to do is I'm going to clean up. I'm going to get rid of the things that I don't need, and I'm going to add in the things that I do need. Now, along the way, I did put in my primes. So those are all appropriately labeled, but I do need to add link number 5 on my object 2 layer. I found where the slider was, but now I need to connect these. So I need to go from C prime to the center of E prime. There we go. Don't forget to add that last link, otherwise it'll look funny. But I can get rid of the construction that I have here. So I can use my eraser and get rid of this circle and this line. Okay. And then make sure that you have the 26 degrees for link number 4, that you have the 0.9544. And then we also want to add in on the notes layer the angular dimension of 15 degrees, or I'm sorry, 30 degrees that we moved link number 2. Okay. Do a quick save. You've got your mobility. And then the very last thing that we need to do is put our pin joints at C prime and B prime. So I'm going to copy there to there and to here. Yeah. And then anything that I don't need, I can get rid of now. I don't need the X, the Y, or that pin joint anymore. Okay. Now, once we're here and we have everything done, now we can take our screenshot and create our document for module 2 practice problems. Okay. So I am going to do my Windows Shift S to get my screen snip. I'm going to window around my area. And then I'm going to go over to, I'm going to use Microsoft Word. You could use Google Docs if you wanted to as well. Bless you. I'm going to go to a blank document. And I'm simply going to make a note that this is example 4.1. Okay, hit enter. And then Control V or paste. You can put your screenshot in place. Okay. Make sure that you have the 0.9544, the 26 degrees, and the 30 degrees. Okay. Yes, Tyler.
One I got for 28 degrees, for the displacement.
Yeah.
I got 28 degrees. For the movement of E, I got 1.5.
Yeah, if you did get different values than what's here, then you didn't draw something correctly or you didn't move it correctly. You're going to have to go back and you're going to have to look. How do I make the background darker in AutoCAD? Okay, I'll show you that in just a bit, Tim. So yeah, unfortunately, these are going to be exact answers. So when you do your assignment, I do have the final answers for all of the problems. If you do get something off and you're doing it in AutoCAD here, then something wasn't laid out correctly originally. Does that make sense? Because you've got the accuracy here. So it's different than when we're doing calculations and we're rounding. There's no rounding here. There's no rounding. Okay. You don't need to see any other dimensions. Nope, you don't need to see any other dimensions, Brooke. Actually, and I think what you're leading to is in the problem statement, they gave us all these dimensions, right? The only thing that I want you to do is label your links, okay? Label your joints, put the symbols in the way they're, the standard symbols, and you don't need to add any of these dimensions because if you get your final answers of 0.9544, 26 degrees, and you add the 30 degrees, then I know you did it right. Okay. I don't need to add any of those things, and it's just going to add detail and make it more cluttered. Does that make sense? Yeah. So all you need are these labels and then the answers that it's looking for. Jacob, do you have a question? Okay,
Okay, on that one.
did you? Yeah.
I
And
do
you'll
have
have
a quick
time, if you didn't
question.
get the exact answer, you'll have time when we go into lab this evening to kind of fix things up and go back, okay? All right.
I do have a quick question.
Yes, Nicholas.
So, with the green lines, for some reason it's not letting me see the hatching, and I missed the part where we just added that dash line part to it because I have it selected, but I have everything drawn. It's not showing that, and I don't know if that's going to be an issue or not.
When you say like the dash line here
Yeah,
or
yeah,
that
like
that
that.
one?
I have it green and everything, but it just won't give me the dash for some reason. Well, I have it selected as dash
So
line.
so all of them are solid looking, you're saying?
Yeah.
Okay, so then remember from tech drafting, you can put in the command LT scale. Okay, LT scale, that means line type scale. Okay, and hit enter. And it should be defaulting at 1. If
Yep.
it's not, is that right?
Yeah, it's at 1 here.
You're
I
at
don't
1.
know if I'm.
So if they're not big, if you're not seeing it, what you want to do is you want to change it to something
Ah.
larger or smaller. So whether it's
Hmm.
0.5, I forget which way this goes. Those get closer, so you probably don't want to go in that direction. So I'm going to do an undo. So you might want to go to 1.5 or 2 or 3.
Yeah, I was able
Should
to get it to
then,
work.
okay, all right, yeah.
Awesome. Thank you.
Yes, you're welcome. And then Tim had a question on how do I make my background dark? Okay, so when you say dark or darker, like black like this, Tim? Yes, okay. So where you want to do that is you're going to go up to Tools. Okay, this is the top item here. To get this, if you don't have it, you have to arrow down next to Share and make sure that you have Show Menu Bar. So make sure that you have Show Menu Bar if you don't have that. So then once you have that on there, you're going to go to Tools, Options, and on Display, so the second tab in, there's Colors down in the area here. And your background color is the very first one that comes up. You should be able to arrow down and pick a different color here. So if you want it to be black, you're going to go there. Okay. And then you should be able to hit OK, and you're good. Okay. I'll do that in just a second, Alex. All right. Any other questions? Okay. I'm going to stop the recording for this.